Awesome. I've always wanted an intro music, so that's pretty chill. Yeah, so I'm talking about automating Spark upgrades, and the tools that we're going to use, they're not just for languages anymore, but it also turns out that they're actually still, it's very important, the language side. Helping people upgrade languages is pretty important. And I think this is an interesting topic because one of the things that we've seen in the Scala community is that getting people to switch to newer versions of Scala can be hard, in part because Spark hasn't always moved the fastest. And then even when Spark is upgraded to new versions, getting people to upgrade their Spark code to the new versions of Spark that allows them to use the new versions of Scala, there's also some hurdles there. So I think this is really interesting from the point of view of helping us not have to backport all of our changes. So I'm Holden. My pronouns are she or her. It's tattooed on my wrist. You might be able to make it out. Yeah. The tattoo got a little screwed up when I got hit by a car. Do not recommend getting hit by a car. Not a lot of fun. If you can avoid it, definitely do. But, you know, lately, big shout out to everyone in the Spark and Scala communities and my employer for being super chill with me just like disappearing for quite some time after I got hit by a car, because it turns out it's kind of hard to type when you break both of your wrists. I'm on the Spark PMC. PMC is Project Management Committee. It's a Apache Software Foundation thing. You can just think of it as like a committer who's really hard to get rid of. And I contribute to a bunch of other projects as well besides just Spark. I'm a co-author of a few books about Spark. Specifically, the most recent one on Spark is High Performance Spark. That book is my favorite book because I get the most royalties for that book. And my most recent book is Kubeflow for Machine Learning. And my publisher would be very upset if I didn't like show you this. Ooh, look. If you have a corporate credit card, now is an excellent time to buy several copies of Kubeflow for Machine Learning. It's not at all related to the talk, but that should not stop you from using your corporate credit card. You can follow me on Twitter. It's just my name. It's a lot of complaining about the world, so I don't necessarily recommend it. Slides tend to go on my SlideShare. If you're interested in sort of like seeing sort of behind the scenes with how things like Spark are built, I do a lot of open source live streams on YouTube. I really like it, and I really like when people come and join. So, you know, if you like code live streams, please come and hang out with me. It makes doing my job a lot more fun. And you can also, you know, look at my code on GitHub, and some of the things that we're going to talk about today. They're pull requests from my GitHub, and I've got a bunch of related Spark videos. And yeah, I work at Apple, but this is not like necessarily Apple's opinions and stuff. In addition to sort of like who I am in the professional realm, I'm trans, queer, Canadian in America. I used to be on an H-1B work visa, and now I'm on a green card. And part of the broader leather community. And I think this is important to talk about for a few reasons. One of the things is like in America, there's a lot of talk about like how immigrants are stealing jobs and stuff like that. And I like to think I'm not doing that, right? Like we're creating, honestly, like I think more awesome opportunities by us all being able to work together. And I think it's also important to talk about our backgrounds and where we're from, so that especially for those of us working in open source teams, if we realize that everyone is maybe, you know, from the same college or everyone is like from the same background of some way, we reach out and try and get more people included who aren't at the table. And part of that is talking about where we're from. And this is just how I feel personally. So what are we going to talk about? Library dependency changes, APIs get deprecated, and eventually we remove them. And community splits are really expensive, right? If anyone remembers Python 2, Python 3, Python 2 was finally end of life this year, right? Similarly, we don't want to see things like that in the Scala community. We don't want to see things like that in the Spark community. Really, any community, you ideally have most of the people being able to share code together, right? Especially in open source. Having these splits can be really expensive. And also just from a like personal point of view, I don't want to have to backport all my changes to Spark 2.4, right? It's just not a lot of fun. And in fact, we end-of-life Spark 2.4.8 very recently. I think that was the agreement. It was like last week, so I could be wrong, but pretty recently. And so I'm really not planning to backport my changes to Spark 2.4, so I want to help people get off of Spark 2.4 as quickly as possible. And also, surprise cake. I like cake. I don't remember why I wrote surprise cake here. I think it's because I got some cake when I was making this slide, but we're going to find out together. It's going to be a lot of fun, and worst case scenario, I'll go buy some donuts at the store up the street. And I'd invite you all to join me for donuts, but it's a little hard over the internet. But next time, we all can do a ScalaCon in person. I shouldn't say donuts are my treat because, like, who knows if I'll have a job by then. But, like, I would love to get donuts with y'all in person. And here is where I really wish I could ask for a show of hands. If we were doing this in sort of like a classic place, I would ask everyone to raise your hands if you're using Spark, and keep your hands up if you're still using Spark 3, and keep your hands up if you're still using Spark 4. And I'm not super sure how the chat system works. But let's just pretend, that a lot of people are using Spark before 2.4, right? A lot of people are using earlier versions of Spark, and that's okay. And Carolyn's coming through because Professor, who is actually in this slide right here, is having a very fun time barking at our neighbors. It's a very important part of the Spark upgrade process, is making sure that your neighbors know you're upgrading to new versions of Spark. Professor Timbit, come on. Okay, well, anyways, sorry. That's the joys of work from home. Okay, so we have a problem, right? Our problem is that people aren't upgrading to new versions of Spark because it's kind of hard. And so because, we're computer scientists or something along those lines, we have a problem, and our natural inclination is to try and fix it with computers. That sounds like a great idea. And so I worked at Google a long time ago, and Steve Yegi wrote this wonderful blog post on Medium, and it's about sort of the impetus to create tooling to automatically upgrade people's code at Google, right? And this is one of the reasons why we see a lot of APIs from Google change pretty frequently. And he says, I played a role in helping become the deprecation-happy prima donnas that they are today when I built Grok, which is a source code understanding engine that facilitates automation and tooling on the source code itself, right? That sounds cool. That sounds like I could use it. I mean, there's some things like prima donnas that doesn't sound happy. And then if we look at the title, deprecation policy is killing you, doesn't sound great. But on the other hand, it does sound like we could use software to fix our problem and then figure out the downsides later. And, that's kind of how my life works.
Do you want a professor?
Oh, I would love a professor. Oh, hello, Professor Soares. Hello. This is my professor. He is an amazing little floof. Yes, he is. And he is very excited about upgrading to new versions of Spark. Yeah, everyone's right there, buddy. Yeah, no, you're more interested in your other mom who's over there.
There's a treat next to your coffee cup.
Oh, yeah, here's the snack. Here's the snack. There we go. Look at the camera. Okay. Okay.
The gate. The white dog is on its stairs.
Okay, so I'm sorry for the interlude. We can get back to the things, and I will hold on to my professor for as long as I can, which might be about 5 minutes. So what are the open source equivalents to Grok? So in Scala, we have ScalaFix. In Python, there's a whole bunch of tools, and that's because Python went through the really painful Python 2 to 3 transition. So there's 2 to 3, Python Modernize, Rope, Bowler, etc. Go actually came out of the gate with GoFix, and I think in part that's because it's from Google, who already had Grok. And there are also generic tools. Sourcegraph is something that's really interesting, and it does more than just one language. Now, that being said, the transformation rules are obviously I shouldn't say are language specific, right? You have to specify their AST transformations. So it's not like I can write one AST transformation and apply it across languages and have it make sense, but it is one tool that can be used in multiple languages. So I think it's pretty cool. They do Java and things like that. So if you're a JVM user, check out Sourcegraph. So most of these have names that imply they're for upgrading language versions or fixing small things. Oh, and Professor Timbit found the other treat. He's a very smart boy. And so that's, okay, maybe not exactly quite what we're doing. Spark isn't a language, but, upgrading language versions and upgrading libraries have a lot of similarities. So maybe we can use these tools to accomplish what we're going for, right? I'd like to think we can. So yeah, how is this related? So in Spark, we deprecate and then delete a whole bunch of crap. Stuff. And so we are going to click on this and, I'm going to have to redo my screen share. We will do this, share screen. Sorry. Screen number 2. So we have a lot of exclusions. So we have a checker that checks to make sure that we're not introducing incompatible changes. But then we just introduce these exclusions every so often, and there's a lot of them. And there's things like missing method. Changes in types, incompatible result type, and a whole bunch of things like this, right? And so that's not great, right? Like it does mean that we are at least somewhat intentional about the things that we break, and we have a pretty good idea of what we've broken. But it's like these aren't small lists, right? Especially, let's look at Spark 3, which is the part that we're really focused on. It's the major version change, right? And we can see here that adding stage level scheduling for executors involved a whole bunch of changes. We got rid of an entire interface, the executor plugin interface. A whole bunch of deprecated items were removed, right? If you were doing k-means training. Oh, actually, let's zoom in because this is maybe a little hard to read. There we go. Yeah, so new metrics, new stage scheduling, getting rid of like entire things. And just like this is a lot of changes, right? And yeah, so remove support for Scala 2.11. That's not a small thing, right? And while this is just listed as 2 little things here, we'll talk about that in a little bit more detail later on. And this stuff, the Spark listener changes, those are really big changes because this is something which we actually expect people to be extending. Similarly, speculative task changes are pretty important. And then all of the machine learning changes. There are just so many of them. And so pretty much if you were doing anything with the ML regression libraries, with trees, you probably had to rewrite a bunch of your code, right? And that being said, though, like a lot of this is just things that were already deprecated. So you probably had an idea that this was coming down the pipeline, but I don't know how many of you actually have no deprecations coming out of your compiler, but I certainly know that at least inside of the Spark project itself, we have a lot of deprecation warnings, and we kind of frankly end up ignoring them at some point. And yeah, so many things removed, so many big changes. The data source v2 changes, very, very big. We changed those APIs a lot. Holy crap. Okay, so that's a lot, right? Now that's a major version change, so that's kind of expected that we would have a lot of really big changes, but that's not a small thing. All right, okay. Okay. So, okay. This is obviously pretty big. We need to do something about this. Let's try and use a tool to just magically fix everything. What could possibly go wrong, right? I see nothing. No problems, no problems. So what does it look like to write custom Scala fix rules to help people migrate, say, the data source APIs, right? In which we looked at, there were a large number of data source APIs that were changing. And honestly, not too bad, right? We write our symbol matchers, then we have our little match on tree function, and then what we can do is we can look and see like, hey, are they doing a data frame reader call on RDDs? If so, that's no longer the way that we want people to make data frames from RDDs of JSON text. So instead we'll go session create, and we'll also have to add some generic import in the SQL encoders. Otherwise, if it's not an RDD, that's fine. Those APIs still work just okay. And then, of course, we have our base case where we're recursing on the children of our tree. And so, similarly in Python, it's a little bit more difficult because, like, for example, writing that same rule would be a challenge because I don't know if what I've got is an RDD of that I'm passing in, because I don't really have that same level of type information, which is why our example here is a little bit simpler. It's just migrating function calls, like we got rid of 2 degrees and replaced it with degrees and 2 radians, and we replaced it with radians. And that's because here, we don't have to care about the type information that's being passed in. And so it's honestly a lot easier. So this make func rename query, we write a query, we look for any instances of the old name, rename it to the new name. And here we set not interactive, but you could, of course, set interactive. And you might do this if you were working, set it to interactive if you were working in something where like 2 degrees was used in 2 different libraries, right? And you only wanted to rewrite some of them. And that's because in Python, we're not going to have that type information. And we really want the user to like take a look and be like, oh, yeah, that's a Spark thing. Or like, oh, no, that's a Pandas thing. No, that's fine. Keep it as is. And yeah, so emphasis, types help a lot. Doing a little bit of poking inside of the PySpark code, even just looking inside of PySpark, greater than 10% of the function names are not unique inside of PySpark itself. And this gets really, really complicated once we start mixing PySpark code with Pandas code. And that tends to be the reason that a lot of people are using PySpark, is because they want to use the Pandas APIs. And this is because Spark borrows a lot of the function names and concepts from Pandas and other data frame libraries. And so writing rules in Python is just, we saw how even for that relatively simple rule, it just wasn't something that we could do, right? Where we couldn't automatically migrate the JSON conversion types. And that's just because we don't have the same type information available to us in Python. And so that's unfortunate. But it's good for the Scala developers, right? We can make really cool use of our magical tools. So what does this look like? Like we've looked at I guess 2 rules, one in Python, one in Scala. What does it look like when we actually run this on a project? And so that's a really good question. I'm lazy. And so while I was working on these rules, I was working on these rules with the goal of writing less code overall. And so specifically, I wrote this tool to use on my own code. And so here we can see I've got a library. It's called Spark Testing Base. I haven't been able to keep it as up to date as I'd like. I'm hoping to get some more time to update it again soon. But it's I need to upgrade its support to Spark 3, and I really didn't want to do that by hand because I'm really lazy. And so let's take a look at some of the automatic changes. Okay, yeah. So we started with the Scala fix base rules, and that was just like I wanted the code to be slightly less, sketchy. And then this one, yeah. and this one. Okay. But so, yeah, the ScalaFix base fixes, a lot of it was just like adding return types of unit and adding return types here. So it was a little bit easier to read. And so applying the base rules, you know, was good, you know. But the Spark specific one, right, we started with, so this constructor went away. And so we started going with the Spark session builder. We can see the import here. How do I say this? The tool for automatically adding imports is, we'll talk about that actually in a little bit more detail later. But suffice it to say, with the version of ScalaFix I was using, it wasn't quite perfect, but it did switch the imports, and so this switched how we were getting our SQL context. You know, relatively simple, but it did save me having to do a bunch of like grepping around in the code base. Yeah. And overall, like the Spark 3 upgrade for this, wait, no, that's not the right one. Here we go. Okay. So we're going to go back into files changed. Yeah. So the Spark 3 upgrade here was a little janky. The bigger things here were I got rid of a lot of old dead code, and that wasn't automated. I had to do that by hand. But you know, overall the tool was pretty okay at upgrading the small things here. Now, to be fair, like this is a testing library, and so it hooks into some internals, which is why if we go back and look at, for example, missing time unit, for example, this is like overriding some stuff inside of org Apache Spark, which you wouldn't do as a normal user. And so I didn't bother creating a ScalaFix rule for this because like this isn't something that really even I should be doing, but I am because we need to fake the time to enable some testing with dstream integration tests. But you know, the tool was able to handle most of the other reasonable things, right? The places where it wasn't so reasonable, those were largely my fault for accessing Spark internals. Okay, back we go. Okay. So let's go ahead and actually look at some of these rules. And the nice thing is, right, like there's a pull request. It is tagged proof of concept and do not merge and has a bunch of println scattered throughout it. But don't let that stop you from taking a look at it, but do let that stop you from trying to use it without double checking what it does to your code, right? Like this is some stuff that I think is cool, but I don't think it's ready for prime time, right? Although, you know, if you want to work together with me on this, you know, pull requests to my pull requester, of course, always welcome. And so, pardon me, we can see the Python one is largely limited to just rewriting function names. And that's unfortunate, but it sort of makes sense given the lack of type information that we have. This is the build file. And then we've got a bunch of the tests here. I really like this because we write our tests as like our, you know, the input and what we expect the sample output is. And the accumulator thing is something that changed pretty drastically from Spark 2 to Spark 3. And we're not able to do all of them perfectly. But, you know, that's okay. We're able to do a lot of them pretty okay, right? Is Professor Timbit singing the song of his people, which is howling because he's not getting any attention. Our neighbors are going to love us once we go back to work in the office. So there's Hive context. This is similar to the SQL context migration that we looked at in the slides. And that's just, we don't construct Hive context this way. We use the builder pattern instead because people really like Java for some reason. The reader one is the other one that we looked at. And so we can see here that we've got a mixture of things that we want to rewrite and things that we don't want to rewrite, right? And that's just to make sure that we're not rewriting everything. And then we've got some stuff to test that we add the imports. We're not just duplicating the imports. Now, these tests are a little brittle because there are, of course, multiple ways that this code could be rewritten, especially with regards to like the import ordering and stuff like that. But that's okay. Okay, yeah, SQL context constructor. Okay, this is starting to get to the point of a lot of very similar things. But we can see what the expected output is here for the accumulator upgrades, Hive context, old reader. So we can see here now that we're doing this encoder's string thing with reading the JSON from the create data set. So that encoder's import had to be added. Well, it didn't here because there was a wildcard import. I think old reader add imports is the one where there we go. So we see here there wasn't a wildcard import, so we did add the SQL encoder's import. Okay. Oh yeah, and so let's actually take a look at some of the rules. Let's keep scrolling. Oh yeah, and meta-inf rules. Okay, so we're going to skip the accumulator one for now because I don't remember it super well. But the deprecated data frame reader functions, I remember a little better. Actually, we already looked at that one. Let's look at the migrating Hive context. So here we can see the Hive symbol matcher. It's Hive context. We look for when it's calling get or create. And we also have this utils add import. And this utils thing, that's some stuff that is local to this. And that's because the version of ScalaFix that I was using at the time had some interesting issues around adding the imports. So I added some extra checks to do it a little bit less frequently. Migrating Spark session builder, very similar to the Hive one. We can see the high quality println debugging, only the finest. And then the utils thing here, not perfect, but just some convenience functions that also worked around, essentially things like wildcard imports not being detected in the add import if not present logic around patch collateral inside of ScalaFix. And this might not be needed anymore, but at the time when I was writing it, it was useful. Coffee. Okay. That's probably enough of digging through code. Let's get back to some slides because I do want to save a little bit of time for any questions. So that's all well and good. Where does this fall down? So a whole bunch of places. The biggest one is dependencies, right? In my super informal survey, the number one reason that was still blocking people from upgrading was the Elasticsearch connector. Didn't support new versions of Spark yet. Now, one could hope, of course, like if we make these tools better, we can help the other libraries upgrade. But, that's perhaps easier said than done. Another one is migrating from Scala 2.11 to Scala 2.12. We don't have great tooling for that at the end of the day. And so the Scala version change is actually pretty surprising, was the number two reason. And the API changes, which is actually what I set out to solve, came in number 3. And as we talked about, there's some restrictions around like the ability to do imports correctly right now with ScalaFix. But, solving number 3, it's not so bad. It wasn't number 1 or number 2, but it probably makes number 1 a little bit better, and number 2, hopefully someone else will get around to solving. But yeah, language versions. I thought, this fixed that, right? Very reasonable. So a lot of the tools like ScalaFix, 2 to 3 and all that stuff, they were created with the intention of helping people migrate. But it turns out that like a lot of people are doing things that are way older than sort of where a lot of these tools assumed people were going to be. And so helping people get from like super, super old versions to slightly less old versions, nowhere near as cool, but I think really big impact potential right there. And yeah, if you ever like want to be sad, just search Migrate Python 2 to 3 and be sad. So in conclusion, the good news, right, is that like we don't have to worry about becoming Google. We haven't made a system so powerful we can just change APIs left and right without thinking about it. The bad news is we haven't made a system so powerful that we can change APIs left and right without thinking about it. The excellent news is that Timbit is very cute, although he does like to howl and bark a little bit. And that's part of why I got to save up some money to get a place where my neighbors don't complain quite as much. But the good news on that one is like it's going to keep me working in software for probably the foreseeable future. Also, distributed computing for kids. I know I keep saying this is coming soon. My friend who was going to work on making the illustrations less creepy actually ended up super booked during COVID pandemic stuff, which is super great for her, super busy. But hopefully she'll have some more time and we can work on making good illustrations. If you're interested in teaching children about the magic of distributed computing, please sign up for the mailing list at distributedcomputingforkids.com. And I think that would be a lot of fun. And with that, yeah. I think I got the timing right. So we're going to do Q&A time. We can see here, this is Timbit. He is teaching another dog how to wrestle. And he's having a lot of fun. This is actually at Presidio Park, which is his favorite park. And the other one is a little puppy. So cool. So Q&A time. Yay. I don't see.
There we go.
Yay. Okay, cool.
Hi.
I was wondering where you were.
Yeah. Thanks so much. As always, you always have entertaining talks, and thanks to Professor Timbit as well.
Yes,
Gotta love
very
a
good
dog appearance. All right. So we do have a couple questions for you. And the first one, multiple people asked this. Can you give a professor a treat for me?
I will. I promise. He will get extra treats right after this talk is done. Actually, my plan after this is I'm going to go outside and do yoga, and he tends to join me, and I bring some treats with me so that he doesn't interrupt my practice too much.
Nice. Good plan. All right. So how likely do you think it is we'll see a Spark version on Scala 3? And if so, what time frame?
Very likely this year.
Okay, great.
Not a promise, right? This is what I think, just to be clear.
We'll cross our fingers.
Yeah.
And will Spark 3 support Scala 2.13?
No.
No. That's a good one. I think, okay. So I think those are all of our simple and to the point. And so if anybody has any further questions, make sure just to add them in the Q&A and we can answer those offline. So thanks again, Holden.
Thank you so much for having me.
Yeah.
I look forward to seeing you all in person again. I would love to get donuts and coffee or you know, if you don't do coffee, something with y'all in person. I miss y'all. Y'all are lovely. Sorry.
Soon. No, soon. hoping soon. All right. Cheers and enjoy your yoga.
Thanks. I will. Bye.